Welcome to Rust Releases. I love Rust and I love teaching people about Rust. If I get anything wrong in this video, please comment below and let me know so I can fix it. Today I'm going over the new stuff in Rust 1.68.0, which was released today, the 9th of March 2023, thanks to the hard work of 380 contributors, which is a whopping 51 more contributors than the last release. That's right, now with 15% more contributors. Nice. Let's talk about some notable changes. Number 1. The Sparse Index Protocol is now available in stable Rust. This new protocol makes updating the index super fast, but it isn't enabled by default. To enable it in a single project in Rust 1.68.0, put this configuration snippet in your project's .cargo/config.toml file. Or, to enable it more globally, export this environment variable with the value set to sparse. Then you get super fast cargo index updates. I set the environment variable because I want this feature always on. I expect this feature will be enabled by default in a future version of Rust. I'll keep my eye on it and let you know when that happens. If you want more details about the Sparse Index Protocol, you can check out my last Rust Releases video. It also includes an interview with Arlo Simpson, the developer who implemented the Sparse Index Protocol. A link is in the description. Number 2. There is a new pin macro in the standard library at standard pin. This new pin macro is similar to box pin in that it pins a type so that its location cannot move in memory. This sort of behavior is important for values used in asynchronous Rust code. However, box pin always stores a pinned value on the heap. The new pin macro pins a value locally instead of on the heap. As this doesn't use the heap, it is in core. So I imagine this opens some doors to asynchronous Rust in some embedded systems where there isn't heap allocation support. Folks often call this stack pinning, but the local context being pinned to could also be the captured state of an async function or block. Since the new pin macro is in the standard library, it can take advantage of the internals of the pin struct and temporary lifetime extension, which means it can be more expression-like than alternatives such as Tokyo's pin macro. So if you're using box pin or Tokyo's pin, try out the new pin macro. Then comment below and let me know how your experience went. Number 3. There's now a default alloc error handler. Not everyone is familiar with alloc, so let's go over a little background first. Alloc is the middle of the 3 levels of libraries that make up the Rust language and standard library. The first level, core, is the parts of Rust that can function without heap memory or an operating system. We usually consider this the core of the language, which is why it is named core. People dealing with smaller embedded systems will often use just core via the no standard attribute, which disables everything but core. Alloc is the Rust allocation and collections library. It re-exports everything in core, adds the ability to allocate heap memory, and adds the collections types like vectors, hash maps, etc. So if you are using just alloc, you essentially have access to the core Rust language and a small portion of the standard library. Finally, standard re-exports everything in alloc and adds everything else that needs an operating system. Think file system or network I/O. So when you are using standard, you have access to the entire Rust language and the entire standard library. Before Rust 1.68.0, if you only used alloc without standard, you needed to use a nightly version of Rust so that you could set an error handler that defined what to do when allocations failed in infallible APIs like box new or VecPush. But now in Rust 1.68.0, alloc has a default error handler that panics when allocations fail. So now you can use just alloc in stable Rust as long as you're okay with panicking being how you deal with allocation errors, which, let's be honest, is usually fine. Number 4. Let's talk about what was stabilized in Rust 1.68.0. The first is the new pin macro, which we already covered in detail. Second, both float types now implement from bool. For both types, that means you can convert true into a floating point 1 or false into a floating point 0. Third, there is now a borrowed string slice constant representing the path separator on your platform, which is a / on all the normal operating systems like Mac OS, Linux, and the BSDs, or a / on the weird operating systems. There was already a really similar constant that was a char, but it's nice to not have to convert this into a string of some type. The fourth thing that was stabilized is a deref mute trait implementation for the PathBuf struct. This is mostly useful so that a mutable reference to a PathBuf can be implicitly coerced to a mutable reference to a path when you've got one but need the other. Deref coercion is an interesting topic, but too big to go over right now, so if you want more details, check out the link in the description. Number 5. One API which was already stable is now also const, meaning it can be evaluated at compile time when used in const contexts. We're talking about VecDeque new. That's right, you can now have your empty double-ended queues set up at compile time. You can only add values at runtime though. Number 6, we have a notable platform update today. Specifically, Rust on Android is now targeting NDK R25, which in other words is API level 19, codenamed KitKat. Seriously, Android, what's with the 3 competing naming schemes? Anyway, that brings us to our bonus round, where we go over interesting changes that were not even hinted at in the release blog post. Bonus number 1. Converting from a vec to a VecDeque is now guaranteed to be a constant time operation. So if you're playing around with a vector and then decide, hey, I should push and pop stuff off of both ends, then go ahead and convert that vector to a double-ended queue without any fear of allocations. Bonus number 2. For all types T, a PhantomData wrapping that type now guarantees it will report a 0 size and an alignment of 1. This was already the de facto and expected behavior for size of, but a line-of was just behaving this way. Now it's documented as a guarantee, so you can count on it staying this way. That's all for today, folks. I love Rust. I love teaching Rust to others. If you enjoyed this, please like and subscribe.